All right, good afternoon, everyone. My name is Phani Gangula, Senior Solutions Architect at ZettaScale, together Julien Loudet, Project Lead and Maestro of the Eclipse Zenoh project. And we're going to introduce you today the Eclipse Zenoh-Flow project. It's a data flow programming framework that is built on top of Zeno. So before we dive deeper into Zenoh-Flow, we want to quickly give you an overview of what Zeno is. Okay. So Zeno is a communication protocol that can scale from a smallest microcontroller up to the cloud. And we do that by providing three simple abstractions, let's say pub, sub, and query. With pub, sub abstractions, we tend to address the data and motion scenario where you have sensors and actuators, right? High-speed data. And with query, we basically address the data in motion and computation scenario. So as a matter of fact, Zeno's query is so powerful that you don't have to, let's say, it provides you a location transparent way to query your data. So you don't have to hard code the address of the queryable. All you have to show the interest on a given query and pass it to Zeno, and it goes to the queryable that is basically sitting behind a storage or sitting in front of storage or a computation, and it gets the information and gets the information back to the query. So through these three simple abstractions, we enable you to build applications that go from vehicle and to the edge where you can do some extra processing, and then to the cloud where you can do fleet management services or other analytics, or you can do a remote teleoperation of a vehicle. So all of that using a single communication technology without having to patch multiple communication technologies. Yeah, that's added advantage. And the second point being, the core of Zeno is written in Rust. But yeah, Rust is well known for its memory safety and content safety aspects. No doubt about that. But today in the morning, when I was talking to Florian, he said a very important point. The amount of static code analysis will reduce drastically if your applications are built in Rust. So that's a productive boost you get by using Rust. So, but don't worry if you're not a Rustacean, we have APIs in all the main languages, from C++ to Java, from Python to Kotlin, so you can build even Android applications. And we have a shared memory support where, with a zero copy mechanism where you can do the inter-process communication. And as you can see, Zeno can scale from a data link layer up to the transport layer. It means you can use the famous TCP, UDP, even quick, but also you can use low-level protocols like serial, Bluetooth, Unix sockets, or even write your own link to PCI Express. We enable you to do that. Having said that, we also have support for raw Ethernet. That means you can also mix the capabilities of time-sensitive networking aspects to basically have more determinism into your communication, guaranteed latencies, and so on and so forth. Having said that, we have another implementation of Zeno, which is completely written in C for the embedded targets like microcontrollers. And as you can see, the payload of the overhead of Zeno's payload is as low as 5 bytes. That means you can use in constrained networks as well. So constrained devices, constrained networks, we have it covered with Zeno. So a topology perspective, if you see on your left, it's DDS. It does peer-to-peer communication only in click. And to your right, you have MQTT, which only does the brokered communication, right? And if you see Zeno, it's a different beast in itself. It can provide it can work in multiple topologies. For instance, in peer-to-peer, it can work in click, where every peer is connected to every other peer. It can work in a mesh communication. You can imagine swarm communication or even a platooning, as a matter of fact. And it also provides you with brokered communication where a client is connected to a router or to a peer and communicate with the rest of the system. So a constrained device, as a matter of fact. And in Zeno, we also have Zeno soft routers where you can deploy them across the wide area infrastructure and have your application connected to that and exchange the data through these soft routers. As a matter of fact, you can imagine a client here doing a Zeno query, and Zeno takes the shortest path if a queryable is sitting on top right, and takes the shortest path and gets information back to you with the help of a small resource, just like you're searching information in Google, as a matter of fact. But what are the frameworks that are using Zeno? There are many applications that are using Zeno, but some of the cool frameworks that are using, or let's say they have implementation for Zeno, is ROS2. ROS2 previously was using DDS, and the users were confronted with number of challenges, starting with DDS discovery or scalability challenges, and not unable to run in Wi-Fi scenarios and so on and so forth. And this is where they did an independent evaluation of all the middlewares that are available out there. They come to the conclusion that Zeno could address these challenges very well. And this is where they have now created an alternative middleware option for ROS2. You can already try the alpha version. It is available. And soon there will be a release where there will be a full support for Zeno. But my favorite project, that is Eclipse U protocol, which is one of the Eclipse SDV projects. And U protocol basically provides you a communication stack with several layers, and they tend to unify the services that are running in the car up to the cloud. And U protocol uses the Zeno as a transport layer for their communication. And they made the choice because they found Zeno to be very, let's say, suitable for the SDV architectures. And the abstractions of what Zeno provides, like pubs and query, are also quite useful when you want to fetch information from your vehicle and from the get that information from the cloud. Having said that, Zeno can also bridge multiple protocols, and that was also quite interesting for General Motors to have a communication when you're running vehicles with the different protocols like SUMIP, DDS, and MQTT. We have plugins for that. I'll come to that shortly. So one big point on Zeno routers. Zeno routers not only routes the data, it also provides you a mechanism to load the plugins. So you can load the storage plugins like InfluxDB up to the file system, and you can also, and the storages are synchronized. Like, let's say if two routers are storing the same data, they basically synchronize. There's a synchronization protocol that runs in the background, and the databases get synchronized, and you can query for these data which is stored in the storages. Having said that, we also have plugins which basically bridge other protocols, and you can also load a Zenoh-Flow into the routers. That means you can load small operators that runs a small business logic, like taking two inputs, deriving an output that sends to a different resource, and so on and so forth. So that's a cool mechanism which we provide on our router. But as you can see, there are a number of frameworks that are being built using Zeno. It could be your next framework that you can build using over Zeno. So with that, I want to pass the baton to Julien. So Julien, please.
Okay. Thank you, Phani. So for the Rust joke, at first, Zeno was written in OCaml. We did the switch a few years ago. So Eclipse Zenoh-Flow. So as Phani mentioned, nowadays it's available, among other things, as a Zeno plugin. But how did it start? So at first, we had a customer that wanted to build a data flow programming framework based on Zeno. The idea was to see if we could replicate the project you can see on the right, which is called Pilot. It's an autonomous driving pipeline. And they saw what was built at the time, figured that maybe they could do something better because it was purely static communication in the sense that it's TCP link. You need to connect. If you want to deploy it on multiple devices, you need to have the addresses quite static. They wanted to bring dynamicity. So the result is normally a small video, but as it's a PDF, it won't play. So here is the Carla simulator. 2 years ago, what we did is that we took Zenoh-Flow, took Pilot, replaced their data flow programming framework with Zenoh-Flow, and made it run. We had some nice results. Interestingly, better performance, although this is, I don't want to trash them. This is academia project. Purpose is to show it works, not that it's the best. So basically, what is Zenoh-Flow? So Zenoh-Flow is Zeno's declarative data flow programming framework, and our purpose, much like Zeno, is to be able to run application from from the thing to the cloud. We are also building it in Rust, we're trying to be performant, and because we're declarative, we know the graph, we know how your application is deployed, we can optimize communication where we can. So quick recap, data flow programming framework, not a complex idea, quite old. The idea is you model your graph, you model your application as a graph with directed links that represent your dependencies. Why we think and why the customer at the time thought that this was useful to mix that with Zeno is that nowadays applications are complex. And so you might not want to run it on a simple device. Possibly in the car, you might want to run it on multiple components. And this is where Zenoh-Flow helps you do that. So instead of having host-centric networking, you have named data networking. So this is the location transparency property that Phani was mentioning. You just need to say resources, and then if you move them from one component to another, it's completely transparent for you. So as a user, as a application developer, much simpler. We're saying we're declarative. So you can see, again, a YAML file. We are not specific to YAML. We just need a descriptor and we need a format. So if there is, for the Rust nerds here, if there is a third something that works, we can use it, basically. We insist on that descriptor because we, just like Rust a bit, we want to bring correctness when you're building your application, meaning that you're going to declare and describe your application, and we're going to try to make sure, we're going to make sure that what you're saying actually makes sense. You don't have nodes that are not connected, you don't have inputs that are not connected, and you don't have to wait at runtime to know that what you're trying to build will actually connect. So this is why for us, we have that descriptor file as contract. The second aspect in Zenoh-Flow, so we're not trying to orchestrate, we're really trying to help you build your application. So eventually you will have code and you will have an artifact. That artifact can be a shared library. For now, we're doing shared library because we want to help you quickly try out your application. There is nothing that prevents us from statically linking that thing to a runtime. We also have bindings available. The last commit is quite recent, so might be a few bugs, but we have Python bindings to help you. And talking about how Zenoh-Flow is right now, we have a data-driven execution model. So if we look here on that graph, we have each node that is running in a separate task, and it's basically waiting for I/O. And if there is one I/O that is available, then the operating system, in that specific case, the async executor will run your node. There is one issue with this. Sorry, there was a lighter. Yes. There is one issue with this, is that you have node B and C that are both waiting for input from node A. So what happens is that node A sends data, then the asynchronous executor can be like, okay, both node B and C are ready to be run next. Except maybe C actually needs the input from B. So if your executor runs node C first, you're wasting CPU cycle. So what we're doing, and this is the rest of my presentation, is how we're trying to go towards real time. So first, what do we understand by real time? So for us, it means that you have the capability at runtime. Ideally, we want to go to enable you to do that at runtime, to decide the location, the duration, the priority, and even a fallback behavior for your different computations. So what do I mean? Mixed up. So how we are going there. So first, we were data-driven execution. Here you can see a prototype that we've been working on with a partner. Not yet available, but will soon be available for Zenoh-Flow. And the idea is that with this execution description, you can specify, instead of having everything running in a data-driven way, like you can explicitly give your dependency, which means that you're going to lose a lot less CPU cycle. You're going to have more fine-grained execution. So that's the first step we want to go to. Parallelism, well, as the name indicates, if you want to run on several cores, then you increase parallelism. What we want to go next is that we actually want to give you the capability to control at runtime with a specific node what should run next. So to give an example, having that what we call custom scheduler would enable scenarios such as behavior trees. So an example we were given, you're in a car, you're driving on the highway. It's not the same constraints and it's not the same graph that you're going to run because you don't have the same constraints. You are in a city, all of a sudden there is a lot more observation to do, and so you have different constraints with different use cases. So what we want to do is allow you to have that custom node, a custom scheduler that would be fed data from the other nodes, and you can make informed decision as to what to run next. Maybe there is a deadline that you missed and you need to skip some computation. So now going back to the different aspects we mean. So what we want to do is we want to give you the possibility to say where each computation should run. So if you want to put it on a specific CPU core, right now it's not a feature we have, but for those who again know a bit Rust, there is the Glomio scheduler implemented by I think Datadog that gives you a thread per core. So you can decide, okay, I want to run that task on that CPU core. So it can be done. Then duration, that we do have a prototype. So we made modification to an asynchronous runtime, and basically we're able to say, okay, that computation should run for, let's say, 500 milliseconds. If it outruns, and this is my next slide, something else will happen. But we're basically capable of saying, okay, you have that amount of time to run. So fallback behavior, what I was mentioning. So in our private fork, what we did was we were able to, in addition to giving a deadline, so how much time you can, or worst execution time, we're also being able to move that task if it outrun on a different executor, and that can be on a different thread. And so what this allows us to do is if we want to have a specific fallback behavior, say you want to put it on the core with the lowest priority and execute it only where there's idle time. Okay, so conclusion. So what have we said so far? So we gave you an overview of Zeno. So we said that we're building Zenoh-Flow on top of Zeno, and that's a declarative programming framework. Now, as a small parenthesis, even though we're built on top of Zeno, because as Phani mentioned, there are lots of nice things that Zeno brings to the table. We don't have to run on Zeno. If your application doesn't go over the network, there is no Zeno that is involved at all. So there is nothing that prevents us to also maybe, that would be a mistake, replace it with some other technology. And I wanted to give you one use case that we're seeing quite a few interest, especially in the robotics community. So what happens is that if you're building, for instance, if you have a warehouse with many robots, you don't want to buy from the same vendor, you want different vendors, and different vendors maybe are talking with different data model. We're already using Zeno inside the robot, either as the communication framework or as a bridge in order to route DDS communication. But then the problem is, how do we make them talk the same language? And this is where you would run a Zenoh-Flow application in here to do the transcoding. We have a small, very, very simple demonstration of that we're working, that is on our YouTube channel. I think we have a YouTube channel, yeah. So if you want to have a look. And we're also, so for those who want to try out, so what's coming up for Zenoh-Flow next is that we are building a platform. So you can run a Zeno router in the clouds to bootstrap quickly your application. We want to integrate Zenoh-Flow inside that PaaS, that platform as a service, such that you can run maybe your transcoding. If you're connecting robots on different continents, then having that would be a good thing. And with 6 minutes, yeah, call to action, try it out, might be a big word. It's still very much in alpha, so, and documentation is sparse. But if you, maybe you should rename it to give us feedback if you think it's interesting. You were happy to share. We are going to do these developments. And yeah, we are available. So Zenoh-Flow is now an independent Eclipse project. And otherwise, you can go and have a look at Eclipse Zenoh. Thank you, guys. Any questions? Yeah.
I understand. So the scheduler is to control the tree where you send the data, not how you receive it. Because I miss the link between the cloud. Because on the cloud, it would be completely different.
So I'm not sure where the cloud fits in, but
Because you started with Zeno.
okay. So with Zenoh-Flow, you can indeed bring the cloud into the mix, but you don't have to. Like our focus is to help you build an application that can span from controller up to cloud, yes. Then scheduler indeed receives data.
What you explained doesn't apply at all to the cloud.
The focus, given the crowd right now, the focus indeed was not really on cloud.
Yes.
We are targeting more application where you would have everything, really more application level. Other questions? Otherwise,
One more question.
sorry, yes.
But you said think to cloud, but it also means in the vehicle, for example. So there could be multiple nodes like ECUs, and they could be running Zenoh-Flow nodes, and there would not be doesn't have to be a cloud, and you have this data traffic there.
Yeah,
Right.
definitely.
And you can schedule.
And it's Rust, right? And
It's Rust, and we have bindings in Python indeed. For prototyping, for robotics community, for instance, Python is a great way to get in. So this is why we're building these bindings. Okay, so, you can, but it's a very simple video. It's just to show that at some point we did it. Yeah. Okay, so basically this is our recording of the simulation. We have an Ego vehicle in the Carla simulator, and we're using Zenoh-Flow for the communication. Basically, it's just trying to show we're saying it go until that red light and then stop. Main key takeaway compared to what they did is that in order to do that video with their thing at the time, so I don't know how it evolves in between, for every frame, they needed to stop the simulator, compute what the action is needed, and then restart simulator next frame. In Zenoh-Flow, you didn't have to do the stopping the simulator, so it kind of was, don't want to put, say real time, so I will put quotes, real time. Yeah.
This is from application level.
Yes. There is no.
Local.
So not, all on local. Basically, we had a big server, and we were spawning two virtual machines, one with the Carla, one with Zenoh-Flow, and yeah. But even them were running on a local host as well. But yeah. Yes.
Yeah.
About the real time, what better schedule from the Zenoh-Flow? The data transmission or the CPU schedule?
CPU.
CPU schedule.
Yeah. So end-to-end deadlines not possible. You need really at the CPU to say, okay, this is how much time you have CPU level. If you are overrunning, we stop you and no data is sent. So it's an Eclipse project. So license model is Eclipse. I'm looking at you, Sarah, because
We have Apache and EPL.
Apache dual license Apache and Eclipse.
Eclipse.
Yeah, Apache 2 and Eclipse. Yeah. We don't have everything open source. So what I said about the fallback behavior and changing to a different executor, that part is not open source, but Zenoh-Flow and the scheduling with so guided execution and the custom scheduler is something we actually want to open source. Yeah.